about bias versus variance, and maybe some of you are not familiar with that term. So just as in normal backtesting, in machine learning, you will always find that your model performs much better on the training data than on the test data. And so the error rate on the training data is called bias, and the error rate on the test data is called variance. So there's a tension between the bias and variance. If your model is very complicated, it will have a high variance, but it will have a low bias. That is correct. Low bias means that the error rate on the training data is low. And if you have a complicated model, you can pretty much fit the data perfectly. That's the problem with deep learning, right? Deep learning has a very high number of parameters, typically over 10,000 parameters to fit. Typical. If you unroll a neural network, the typical neural network has 10,000 parameters. So you can fit 1,000 rows of data quite perfectly. You practically can make perfect prediction on your training set with a neural network with 10,000 parameters. Very, very low bias, maybe zero bias. But does it work out of sample? Most unlikely to work. You will have a very high variance in our out of sample set. So that is typically what's happening. As if you plot this diagram, the error rate as a function of increasing complexity of model, you will find that the bias will decrease, maybe to zero, but the variance will increase in the out of sample data set. Now notice that it is also not recommended to have a model with too low complexity. So that's why we avoid linear model as well, because in linear model, both bias and variance can be high. The model is too simple to capture the interaction between the features and the target variable. So when you have a too simple model with too few parameters, you can have both high bias and high variance. So this is the regime where you have both high bias and high variance. We don't want that. But again, we don't want a too complex model where the variance, where the bias is almost zero, but the variance is still very high. We don't like that. Very high variance, but very low bias. We don't like that either. So this is the sweet spot. We want to find a regime which has the lowest error in the test set. Who cares about error in the training set? That's nothing that we can use. But error in the back test, the test set is what we're concerned with. That is the variance. Minimizing variance is really our goal. And you can see from this diagram, which is something taken out from somebody else's website, not mine. So, but that agree with our choice to use random forest, because in random forest, the complexity is about intermediate. It is not too low, like the linear regression or logistic regression. It's not too high, like the deep learning. It is sitting right at the bottom, so as to minimize variance. Not to minimize bias, but to minimize variance. That's why we pick random forest as the machine learning algorithm for financial data in particular. Okay, so and our choice is supported by another research paper, which is published not too long ago. It's published in 2019. It's called Macroeconomic Forecasting Using Alternative Data. And the author compare different kind of machine learning algorithm. They compared essentially the variance of different machine learning algorithm on macroeconomic data. And once again, it finds that random forest ranked the lowest in terms of variance. And the simple models such as boosting and linear regression ranked the highest. Interestingly, they didn't compare neural network, because chances are that most people in the finance and economics community dislike neural network. That's why they don't even bother to include it, because everybody knows that it doesn't work. Any reputable people know that it doesn't work. So nobody even bothered to include it in their research anymore for reputable researchers.